Hi, I'm Shawn Smallwood. My title is Long-Term Population Trend of Burnouts in the Altamont. The reason for my study is because wind turbines in the Altamont Pass wind resource area were estimated to kill hundreds of burnouts per year at a place where I estimated 537 breeding pairs in 2011. We need to understand the effects of repowering, which is the conversion of the old generation turbines to fewer, modern, larger turbines. My study objectives were to estimate abundance, distribution, non-breeding season use, and effects of repowering across 16,760 hectares of grassland, an area that's host to one of the largest populations of burrowing owls remaining in California. Some background references are listed here. I randomly selected 46 sampling plots in 2011. I added extended sampling areas next to high density plots. Those are bounded in purple. I added vascular caves and 10 plots in 2016 to offset temporary or permanent loss of access to some plots. I searched each plot many times from April through August and year round in 2011, 2012 to get seasonal use. I mapped nest sites, counted chicks, monitored ground squirrels, and in 2019 I revisited nearly 800 nest sites I mapped from 2011 through 2018. The graph in the top left shows nest attempts per square kilometer. And what I take from this graph is a possible population cycle with a 6-year period and an overall decline by about 33% in the nesting population through the study. On the top right, we see successful nests per square kilometer. On the lower graphs, we see chick production interannually. These are changes in nest density per year in select plots. And there's examples of increasing or decreasing burrowing owl numbers, and also some bouncing around from year to year. You can see the temporary impacts of repowering construction, and you can see longer term impacts of squirrel control in the bottom graphs. The graph in the top, the lower left is number of burrowing owl nest attempts per square kilometer at Vasco Cage Region Preserve. The high densities to the left of the graph were established by Jack Barclay, who surveyed the area in 2006 and 2007, and I resurveyed the area from 2016 to 2019. I found very few burrowing owls trying to nest there. Also during this time, I monitored ground squirrels throughout, and what I found is the ground squirrels declined with the sheep grazing. So that's my only explanation I can come up with right now for why we lost the burrowing owls in this area. Sheep grazing and ground squirrels don't seem to get along. The image on the right shows the difference between a sheep grazed area and cattle grazed area, a much greater difference in cover. Here's the density class of burrowing owls in 2011. So the red zones are the higher density, and they tend to be more centralized portions of the Altamont Pass. And for perspective, this the Highway 580 follows my mouse cursor here. Livermore is to the left, Tracy's to the right. Now I'm going to skip a few years and go to 2015. Here's the density classes then. There's much less high density burrowing owl nest attempts. They're right here, plot 12 and plot 14. Here's 2018, so the density picked up again. And then here's 2019 where it's dropping off again. And here's the average chicks per square kilometer among years. And you can see that the highest chick production is where the nest density is also highest, the central middle part of the Altamont, and tend to be lower in the peripheral aspects of the Altamont. This shows the change in density among plots from year to year, starting in 2011. So this nest attempts per square kilometer in 2011 is the x-axis in all the graphs. And then we look at the the density of nest attempts from each year since 2011. So the best fit regression line, which is red, falls right on the line of equivalence in between 2012 and 2011. So you can pretty much predict 2012 nest distribution or nest attempt distribution based on 2011 data. But then the relationship falls off after that. Every year after that, it gets worse. The regression line drops away from the line of equivalence, and our predictability drops. I'd say by year four, it's pretty bad. These graphs show the shifts from 2011 breeding season owl density to the following summer, fall, late fall, and winter. So data points below that dotted line are losses of owls, and data points above the dotted lines are gains of owls. Because plot 12, this point here in summer is plot 12, and we had a lot of chicks there, so you had a gain. And the owls are still there. Many of the owls are still there in summer, but by fall, late fall and winter, the owls in plot 12 drop off and fall into line with the rest of the trend in the Altamont. So it's shifting away from the breeding areas. They go from the breeding areas to non-breeding areas, but there's a shifting away. And I think that they shift away because they need to rest the forage in the breeding areas, and they also need to escape predator and parasite loads. But a grand takeaway here is that burrowing owls need more habitat space than measured in the breeding season. They also need the habitat space of the non-breeding seasons. Here's a shift to the 2012 breeding season density from the preceding summer, fall, late fall, and winter. Here, there's not much going on. It's hard to predict where the owls are going to be based on preceding seasons, or seasons preceding a breeding season. I'll add that locations of pairs in March and April are often exploratory. Many nest sites are not established until May. One of the grand results is that based on the before-after control impact analysis of variance tests, there were no significant effects on burrowing owl nest density or productivity from wind turbine removals or modern wind turbine installations with repowering. Here I point out that the density of nest attempts more than equals chick production. So I regressed mean chicks emerged per square kilometer on mean nest attempts per square kilometer, and I found a regression slope of 1.66, which means that the increase in chicks is more than proportional to the increase in nest density. You get more bang for your buck, basically, you might say, in terms of chicks for the nesting effort. Where nesting effort's higher, you get more chicks. Many more chicks than you expect. So there's clusters of successful nests, which we identified in GIS. These red lines bound those clusters. Burrowing owls are closer to clusters, tend to have more breeding success. The burrows, or owl use of burrows are farther or farthest from the nest clusters, or successful breeding clusters, I should say. They tend to be non-breeding refuge burrows. So they're moving away from the breeding areas and during the non-breeding season. And also those that are farther from these clusters during the breeding season are more likely to be abandoned early or not successful. And I want to point out this cluster of successful nests right here. I'm going to go to the next slide is going to show visually what that place looks like. Here it is. This is part of plot 12. So you can see the scars of ground squirrel burrow systems, ground squirrel burrow systems here, the lower third of the slope, right in here. And the burrowing owls would distribute themselves among these burrow systems in here. I found there's more burrowing owl nest attempts among plots with ground squirrels. So among all the sampling plots, those that had moderate or many ground squirrels in 2019 had the highest burrowing owl nest attempts. And those that had no ground squirrels had no nest attempts. The map on the left shows these successful breeding clusters of burrowing owls in red, which are hard to see, but if you squint, you can look in the plots where I mapped squirrels or squirrels either occurred or they didn't occur. The breeding clusters occur where they overlap the areas that had ground squirrels, and they just don't occur in areas without ground squirrels. And on the right, we see nest attempts regressed on the number of squirrels from 16 vantage points where I can look over slopes and readily count the squirrels in 2019. On the left in the map, you see the change in the extent of ground squirrel colonies from 2011 to 2019. So the red zones show where there are no squirrels in 2011, but I'll point out that most of these had squirrels, lots of squirrels. You know, when I started my work in the Altamont Pass in 1999 through 2003, there were a lot of squirrels there, but between then and 2011, the ranchers controlled the squirrels. And the orange polygons show the plots that had 40% to 100% reduction in squirrels. And the dark green show where you actually had squirrel increases. The graph on the right shows that ground squirrel or burn owls increased in their nesting attempts where the squirrels increased. But where squirrels decreased, we lost burn owl nest attempts. The maps on the left show some select areas that had high, lots of burn owls in 2019. And the squares are ground squirrel burrow system centroids. The circles are where the nest sites were for burn owls. And on the right, you see a map that's blown up from the bottom left map. And this shows how I came to a neighborhood level analysis where I measured the distance to the nearest neighbors from a point, and I would count up the squirrels at those nearest neighbor ground squirrel burrow systems. And there are two types of neighborhoods. There's a focal burrowing owl neighborhood and a focal ground squirrel neighborhood. So at A, we have 18 ground squirrels in the focal burrowing owl neighborhood. And at site C, we have 22 squirrels in the focal ground squirrel neighborhood. For these neighborhoods, I measured ground squirrel density and whether the neighborhood was outside the nest, burrowing owl nest neighborhood, within the nest neighborhood, or within a successful burrowing owl nest neighborhood. And what you see in this graph is the numbers or the densities of ground squirrels are highest within the successful burrowing owl nest neighborhoods, and they're lowest over here when they're outside the burrowing owl nest neighborhood. So ground squirrels benefit from burrowing owls, and it's both ways. Burrowing owls also benefit from ground squirrels. And the reason why is because they both mutually alarm call. So with incoming predators, either ground squirrel will alarm call or burrowing owl will alarm call, and they both benefit from avoiding capture. I also noticed that as eagles come in, whether it's a ground squirrel or burrowing owl that alarm calls, everybody, both species, look up and in the appropriate direction. If a coyote is approaching, either the ground squirrel or the burrowing owl calls, and they all look laterally in the appropriate direction. When rattlesnakes come in, ground squirrels alarm call, and the burrowing owls go to work on them very aggressively, dive bombing them, hitting them, sometimes even killing them. So I revisited 800 burrowing owls, or almost 800 burrowing owl nest sites I had mapped 2011 through 2018. So in 2019, I went to all of them. And using logistic regression, I predicted the probability of revisiting the probability of a revisited nest burrow hosting nest attempts in 2019 with time since the last nest attempt. So with each succeeding year since the last nest attempt, the probability dropped as shown in this graph. And it wasn't even 12%. It wasn't not even 12% from one year to the next. So from 2018 and 2019, pretty low fidelity. In the image, you can see there's a burrowing owl here in the middle, and there's a burrowing owl here over here. There's a pair of burrowing owls basically, and there's ground squirrels right next door. I broke out the logistic regression based on whether the ground squirrel complex was inactive in black or active in red. So you can see here that the action really is in the, it's mostly in the active burrow. So if you don't have if the burrow system is inactive in 2019, your chance of having a burrowing owl there is pretty low. Or a burrowing owl nest attempt, I should say. And similar for ground squirrel. So the proportion of ground squirrel burrows that were active upon my revisit were highest when the last of the nest attempts were in 2018 or 2017, and it dropped off from there to the left. The mean number of ground squirrels within 25 meters of the revisited burrow that have been used before by burrowing owls was highest where the burnout burrows were intact still, and then dropped off where the burrows had collapsed, and dropped off further when the burrows were gone. In conclusion, nest site fidelity is much higher than nest burrow fidelity, and burrowing owls are declining in eastern Alameda and Contra Costa counties as they lose ground squirrels and habitat. And I want to acknowledge all the people and organizations that helped out with funding, with logistics, with access, and GIS support, and particularly those who came out and helped me with the surveys. Thanks so much.